previous lecture we looked into functionalities and working of data link layer into detail, and moving further, today's topic is about data link layer protocols. So, when I am saying data link layer protocols, the agenda is very simple. We are going to consider the protocols which are going to be used at a data link layer. So, in this lecture we are going to cover a few protocols by their increasing complexity. So, previously, or at the inception we will be having the simplest protocol, and then we will keep on exploring more protocols as their complexity increases. But before going into the concept of protocols, let us try to understand the whole scenario around which this whole concept is working. In the sense, I am looking for whatever what kind of network it is, what are the assumptions. So, here we will be following in this lecture, we will be following, or we will be working with some assumptions which are we can say rigid at first, and then they become diluted as we move further. So, physical layer, so the assumption goes like this, that physical layer, data link layer and network layer all are kind of independent processes that communicate by passing messages back and forth. So, network layer needs to pass messages to data link layer in turn pass it to physical layer, and at the receiver's end this is going to be opposite. Physical layer will pass some messages to data link layer, which in turn give the messages to network layer. So, this is kind of a first assumption, that these are independent processes which communicate by passing messages back and forth. Physical layer processes and some of the data link layer process run on a dedicated hardware called NIC, and this hardware we have already learnt about. This NIC is nothing but network interface card. So, physical layer and some functionality of data link layer is working on is running on this NIC, the dedicated hardware. Rest of the data link layer which is remaining, and the network layer, which is obviously we need to consider in this scenario, these processes run on the main CPU as a part of operating system, and the software for link layer processes often taking the form of a device driver. So, the software which are being used for link layer processes are device drivers. Some of the link layer is working on NIC, some of the link layer is working on CPU as the part of operating system. Whole physical layer is on NIC, and your whole network layer is on CPU. So, let us try to understand this whole assumption with the help of a figure which is shown here on the screen. So, we have a computer system. In this, if you can see, I have just earmarked only the 3 layers, and rest of them I have marked them as kind of application and other higher layer, other higher level layers, which I am not worried about as of now, or as as far as data link layer is concerned. So, NIC, that network interface card, you can see the whole physical layer, or kind of the cabling and all those things are going on here, and this NIC is also having some of the kind of link layer functionalities, data link layer I am talking about. Then moving further, or moving on to the top, if we looked into the computer system, there are device drivers. There are device drivers which are the softwares inside the operating system or within the operating system. They are working for the functionality of data link layer, that portion which is available with the operating system, and the whole network layer is also working as a part of computer CPU, or we can say operating system is getting operating system is managing this. So, this is what one of the assumptions. Moving further, for the first protocol which we are going to consider, another key assumption is that there are 2 machines, machine A and machine B, where machine A wants to send a long stream of data to machine B. However, the requirements here are the connection should be reliable and a connection oriented service. Later on we will see that what will happen if B wants to send data to A simultaneously. So, presently we are not going to take a full duplex system, only A wants to send a long stream of data to machine B. So, only one sided communication is going to take place, that kind of model we are talking about, not the full duplex model. Now, A, which is our sender, is having an infinite supply of data ready to send. That means your sender is not waiting for the data to come over and then it will send over the data. No, nothing of that sort. It is having an infinite supply of data ready to send and never has to wait for the data to be produced. Instead, when A's data link layer asks for the data, the network layer at the machine A is always able to comply immediately. That means always able to send the data immediately without any delay. So, there is no dearth of data at the sender's end. Now, with all these assumptions that only sender and sender and receiver are fixed, A wants to send some data to be on a connection oriented reliable service, no dearth of data on the sender side. Let us begin with our first protocol, which is a kind of a very simple protocol we can say, and it is named as Utopian simple protocol. So, Utopian simple protocol, when we talk about, let me tell you, it is a hypothetical data link layer protocol because of all of the assumptions we have taken. The assumptions we have taken that the data is transmitting in one direction, that means nothing kind of duplex, full duplex kind of transmission is not allowed here. Here it is only a simplex kind of the network for the data transmission. So, data is being transmitted only in one direction. Also, channel is kind of ideal in the sense it is in kind of error free, it is reliable, infinite buffer space is available at the sender as well as at the receiver. So, we cannot say that sender is kind of sending and receiver is not able to take that up, or receiver is kind of feeling overwhelmed with the deliveries, nothing of that sort. So, Utopian simple protocols, because of all these assumptions, this is considered as a hypothetical data link layer protocol, because practically these kinds of assumptions are not going to work. We cannot have an ideal error free channel in which there is no kind of no errors, no noise, nothing kind of we can say the data is not getting less or something of that sort, buffer space is infinite. These things are actually hypothetical we can say. But important is that if the protocol that we are talking about Utopian simplex protocols, and we are saying ourselves that it is a hypothetical protocol, then why are we studying this? Although it is kind of an unrealistic for practical implementation, this protocol serves as a fundamental concept to understand the basic structure of more complex and usable data transmission protocols, which we will which will be covering, which will definitely covering in our upcoming lectures. Although this is kind of an unrealistic, but as we move on, we will keep on tightening our assumptions, we will keep on restricting them. So, presently we are going with the this particular protocol, because this is important as far as we need to kind of understand the whole fundamental concept or the basic structure of the more complex protocols. Now, this protocol also assumes that sender and receiver are always ready. So, that means no party is waiting for any communication or any signal to be received or something of that sort. So, this allows data to be sent and processed immediately, instantly, without any need for there is no need for error control mechanism. There is no need for flow control. So, error control mechanism including some sequence numbers and acknowledgements, these are the things which will be covering in our next protocol. So, it assumes sender and receivers always ready, pretty kind of we can say no dearth of data, too much of data is already available which can be processed instantaneously without, so flow control is also not needed, neither the error control mechanism. So that is why, because of these, all these assumptions seems as kind of an unrealistic protocol, but still in order to understand the fundamental concept, as I have already told you, this is important to kind of study. So let us see how this works. So sender, at the sender end, if we can see, the sender continuously fetches the packet from the layer above, which is nothing but the network layer, immediately creates the frames, which is the job of data link layer, and sends them to the physical layer, which is the layer below it, for transmission to the receiver's side, and this whole thing is happening without any wait, without any delay, or without any kind of checks being applied on to it. If we talk about the receiver side, the receiver waits for an frame to arrive, not only a frame but an undamaged frame to arrive, because we have taken this assumption that this whole channel is kind of an error free and reliable channel which is not going to disrupt the data at all. Then as far as receiver is concerned, upon arrival it is going to take the frame, passes the data to the network layer, and then immediately return to its waiting side. So it is simple, we can say it is just a communication between sender and receiver. The communication is unchecked and kind of undelayed also because of the assumptions. Now what all assumptions we have taken for this utopian simplex data protocol. So even if we write to even if we want to write a program of this particular data flow in this kind of particular data protocol, maybe in your any of the language, let us say C++ or something, taking some key assumptions, we need to kind of we can say we need to code only on the sender and the receiver, we can say within a loop. So that loop suffices. So what were the key assumptions? First key assumption was the unidirectional data flow, that data moves only in one direction from sender to receiver, no duplex, nothing of that sort. Channel is ideal, communication channel is perfect, no possibility of data loss or errors during the transmission. Another key assumption, moving further, instantaneous processing, no delay, no waiting, both the sender and receiver processes, both the sender and receiver process the data instantaneously, immediately, and have infinite buffer space, so that there are no delays or overloads. Now these kinds of assumptions I have already told you are purely hypothetical. Error control mechanism is not at all required, because we are not assuming that any errors are going to occur. So there is no mechanism to detect or correct errors, as errors are assumed not to occur. And because of this thing, there is no need for flow control also, because the receiver can always process the data as fast as the sender is sending it. So sender is sending it fast, so is receiver is getting it fast and processing is fast. So this was the whole structure of your utopian simplex protocol, in which none of the sites is kind of we can say either stopping or waiting. Now these two words, which are stop and wait, are going to build the foundation for our next protocol, which is a stop and wait protocol. Now what is the difference between the previous one and this one? This is kind of this stop and wait protocol is going to be a little restrictive. So first of all, let us try to kind of explore this stop and wait protocol. So this is more specifically or more technically known as simplex stop and wait protocol. And another thing which is worth noting down is it is for the noisy channel. Noisy channel, that means noise is going to be kind of introduced. In this noise, what all can be the effects of this noisy channel, that we look into. So it is, this stop and wait protocol is a data link layer protocol for data communications error control mechanism as well as flow control mechanism, both are needed to be kind of taken care of, or we can say both are needed to be implement. Now this stop and wait, simplex stop and wait protocol is more popularly known as stop and wait ARQ, and I am sure in the previous lecture, if you remember, we have talked about this protocol in a very brief. So ARQ is automatic repeat request. So popularly this simplex stop and wait protocol is known as stop and wait automatic repeat request ARQ protocol. And what is the major difference? It adds the error control facilities to this stop and wait protocol. So error control facilities and flow control mechanism are being added, which was actually absent from our Utopian simplex protocol. Now again, if we talk about the flow control mechanism and error control ideas, these protocols are actually designed to ensure a reliable data transmission over a channel which is noisy. So noisy channel here is going to kind of get into a high probability of errors or data loss. So there are probability of errors, there are probability of data loss, which are obviously which are needed to be taken care of. In simplex, Utopian simplex protocol, we have just closed our eyes from all these nuances or all these practical disturbances. In computer networks, when we talk about these protocols, they are typically used to overcome the effects of channel noise during data transmission, and channel noise during data transmission is actually a reality. We cannot have an ideal channel which is not producing any noise, or which is kind of 100% free from the noise. What kind of noise I am talking about? So there can be an attenuation, there can be electromagnetic interference. So noise because of electromagnetic interference, or noise because of attenuation. Because of these noise or these disturbances, your signal is going to get degraded. So all these things are needed to be taken care of, all these interferences. So and because of this flow control mechanism will be required. It is a possibility that maybe your sender is fast, receiver is slow, or it could be other way around, or even error control facilities are required. So when we talk about the simplest noisy channel protocol, that is ARQ, which is your stop and wait ARQ protocol, and this protocol is basically used in many network protocols such as TCP. So within the TCP you will find kind of these ARQ protocols, and as I am talking about TCP, one thing is very sure, I am talking about a reliable kind of data transmission. If there is UDP, the transfer can be faster, may not be reliable, but as far as TCP is concerned, it ensures reliable data transmission. Now what is the kind of scenario in which this kind of protocol is being operated upon? So receiver is having a finite processing speed, and because of this finite processing speed, what will be the kind of effect? The frames may get corrupted while transmission. That is also a possibility. Your receiver is not able to process them as your sender is sending them. Even if the data frames arrive at the receiver and at a rate which is greater than the rate of its processing, frames can be dropped out. So you can drop the frames, you can lose the frames, or frames may get corrupted, or it could be entirely lost when they are transmitted via network channels. So all these now from this simplex stop and wait protocol, practically speaking, we have started taking the realities onto into the consideration. In our Utopian, we have not taken any realities into the consideration. So in order to kind of keep a check on this, that how many frames are being dropped out, how many are being lost during the transmission, your receiver is going to send an acknowledgement for each valid frame that it received. So, what is valid? Valid in the sense that the frame is actually intact, or the frame is same what was being started from the sender side, same has been received from the same has been received at the receiver side. So, receiver is going to send an acknowledgement for each valid frame that it received. So, now this acknowledgement thing is something new which we are introducing in this protocol. Now, sender has to wait for this acknowledgement, and sender sends the next frame only when it has received a positive acknowledgement from the receiver that it is available for further data processing. So, for example, there is a particular frame number. Now, one thing which is newly introduced here is the frame number. That frame number starts traveling from the sender to receiver. Unless your receiver is going to send an acknowledgement for that particular frame number, new frame is not going to be, your sender is not going to start the new frame or the next frame. Now, what will happen if there is no such acknowledgement? So, then in that situation your sender will wait for certain amount of time, and then it resends the frame. So, this is going to be the whole idea of your this is simplex stop and wait ARQ. ARQ is automatic repeat request when we talk about. So, automatic repeat request is kind of your sender is waiting for a certain amount of time to get the acknowledgement, and if acknowledgement is not being received at the sender's end, it is going to resend the frame. So, this protocol, if we talk about in totality, is kind of simple as it sends the data packets and requests the acknowledgement of receipt from the receiver end. If the sender does not receive an acknowledgement from the receiver within the specified time period, it assumes that the packet was lost or corrupted, and hence your sender is going to resend it. So, if you can see the whole idea, the idea actually is kind of the simple. So, this protocol works by transmitting a single data packet, waiting for the acknowledgement before sending the next one. In this ARQ protocol, because others or also some ARQ protocols are different from this. The sender sends a data packet to the receiver, waits for an acknowledgement from the receiver side. The receiver at its own end or at the receiver's end, after receiving the packet, sends an acknowledgement back to the sender indicating that the packet has been successfully received. So, this was actually we can say the idea. So, here in this figure you can see. So, now there are two parties, obviously sender and receiver A and B. So, frame 0 is being sent from A to B, then there is an acknowledgement from B to A, then it is going to send another frame, and then there is an kind of acknowledgement for that frame. So, for example, what happens here, there is a frame 0, the corresponding acknowledgement, then there is a frame again which is frame 1 from A to B and the corresponding kind of acknowledgement. Then there is another frame, and the cross here indicates that the frame is somehow kind of corrupted or get lost. It is not being delivered at the side B. Now, if you can see on the side A, the frame 0 is actually lost within the channel. Then for a particular time, your A is going to wait for this acknowledgement. Now, acknowledgement obviously will not come because frame has not been received at side B. Then again this frame 0 is kind of repeated, acknowledgement comes up, then again next frame is going to be sent. Now, in the next, if you can see the next cross here, the next cross shows that the acknowledgement is not being received at the side A. Now, what will happen if the acknowledgement is not acknowledgement is lost somewhere. Frame is received at the side B, but acknowledgement of that particular frame is not being received on side A. So, A is going to assume that, because in the absence of the acknowledgement, A is going to assume that that frame has not been delivered. So, after waiting for some time, your A is going to kind of, we can say, retransmit that particular frame for which acknowledgement has not been received. So, in this way, it is also kind of a situation in which your B is going to have that frame in duplicate. So, what is the responsibility of B? The responsibility of B lies here, that it discards the duplicate frame. So, this is actually kind of the original idea of your this stop and wait ARQ, simplex stop and wait ARQ protocol. But there are kind of some differences, some key points which are to be considered in order to complete this we can say this topic of stop and wait ARQ protocol. I will be definitely covering all those important points in my next lecture. Here is a list of references which is being used for the preparation of this. I will see you in the next one with all those leftover details. Till then, take care. Goodbye.